This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are covering the topic of shear force and bending moment diagrams in mechanics of solids. Whenever horizontal beam, here beam is nothing but here now, it is horizontal beam, it is there. Beam is loaded with the vertical loads. The vertical loads means the loads which are acting perpendicular to the beam. Generally, it bends due to the action of the forces. Like it bends. The amount of which it bends, it depends upon the magnitude of the forces that are acting and the length of the beam, elasticity of the beam, and type of the beam. The scientific way of studying the deflection or any other effects due to the action of the loads can be analyzed perfectly by drawing shear force and bending moment diagrams. The shear force means it is a vertical balanced force with respect to the left or right of the section. Generally, it is treated as the algebraic sum of the unbalanced vertical forces which are acting on the beam when we are considering from the left or right of the section. The bending moment at a cross section of the beam may be defined as the algebraic sum of moment of all the forces to the right or left of the section. Here the moment is defined as the product of force and perpendicular distance from the point of application of the force to the reference point. The beams are classified into here 5 terms we have taken now. It depends upon the type of the support it is having now. The first one is a cantilever beam. The beam which is fixed at one end and other end is free as shown in figure. Here it is known as a cantilever beam. The distance between the fixed and free end, that means from this point to and this point, here it utilizes the length of the beam. The second one is simply supported beam. That the beam is laid on two supports at its ends as shown in figure. These supports may exert vertical reactions on the beam because of its own weight as well as the forces which are acting downward directions. But the moments created by the supports is treated as zero only. Hence, it is treated as freely supported at its ends. That means there is no moments acting at its points. That is at the supports. The third one is overhanging beam. The beam freely supported at any 2 points and having one or both the ends projected behind the supports is called overhanging the beam. The beam which is shown in figures 1 and C are overhanging beams. Here in this case, here support is 1 is given here now, the second one 2 is there now. The beam is projected just behind these supports. Sometimes it may be the both sides, sometimes it may be the one side, it may be toward the left side or right side. Hence, this beam is treated as the combination of simple supported beam and the vertical and cantilever beam. Here example, here it is now overhanged toward the right hand side of the beam. The distance between these two supports, here 1 and 2, it is treated as a simple supported beam. Between 2 and this and it is treated as a cantilever beam. So hence the overhang beam is treated as a combination of simple supported portions as well as the overhanging portions, which is nothing but equivalent to the cantilever. The fixed beam, the beam whose both the ends are fixed, are built in walls known as fixed beam. Such a beam is shown in figure in D now. The beam is also called built-in or encasted beam. Continuous beams, the beam which is provided more than two supports along its length is known as continuous beams. These supports may be placed at regular intervals or at convenient distance between the supports. Cantilever is simple supported. Here for this beam, one end is fixed and the other end is supported with the knife edge or ball as shown in figure. This type of beam is known as a cantilever simple supported beam. Types of loading acting. Here shear force already defined, it is the unbalanced vertical force which is acting on the beam, or it is treated as the algebraic sum of the vertical loads which are acting perpendicular to the beam, considering from the left hand or right hand portion of the beam. These vertical loads are classified as one is a point load, or it is also called concentrated load. The second one is uniformly distributed load. Simply it can be written as UDL. The third is uniformly varying load. It is also called UVL. Here the point load and concentrated load, they are already told it is acting at a particular point on a beam, or it is concentrated at a one point, which is shown in figure LI. Generally, it is represented as a vertical line acting in downward directions to represent the load acting on the beam. Uniformly distributed load, which is the load which is spread over a beam in such a manner that it varies from one end of the beam to other end uniformly on each unit length is known as uniformly varying load. Sometimes the load is zero at one end and increases uniformly to other. The load is known as the form of triangular load. Uniformly varying load is also called UVL. Here these vertical loads, depending on the direction in which they are acting, but these are always perpendicular to the axis of the beam. Some forces may be acting in downward directions, some more may be acting upward direction with respect to the reference point what we have taken from left or right hand side portion of the beam. They are classified as positive as well as the negative forces. At the same time, the bending moment created by the forces also having sign conventions. Okay, these are sign conventions are important for drawing shear force as well as the bending moment diagram, or in other words, to determine the magnitude of shear force as well as the bending moment at particular sections as well as its effects on it. The shear force is the unbalanced vertical force. Therefore, here I am taking the force now. Here the beam is given, just here it is simple supported beam, having two supports A and B as shown in figure. Here now it is subjected to a load of vertical load of 100 newtons at a point C. The effect of the force with respect to the section here axis, it is acting downward directions. That means the effect of the beam is with respect to the axis, it tends to slides in downward directions. Here always we are now considering it a positive or negative, generally by considering the left hand side portion of the beam now. That means with respect to the left hand side portion of the beam, the load at C tends to side the beam in downward directions with respect to axis. Hence, this force is treated as a positive force. Similarly, the reactions at B, it is there now. At B, it always tends to slide the portion of the beam between B and X in upward directions. That means it tends to slide upward with respect to the left hand side of the portions. Hence, this vertical force which is acting at B is treated as a negative force. Or in other words, with respect to the left hand side portion of the beam, the forces which are acting in downward direction are treated as a positive, and the forces which are acting in upward direction are treated as a negative forces. Similarly, when we are considering right hand side portion of the beam now, the forces which are acting in upward direction are treated as a positive shear. The forces which are acting downward direction are treated as a negative now. Bending moment. At the section where the bending moment is such a way that it tends to bend the beam at that point to a curvature, having concavity at the top as shown in figure 1C is taken as a positive now. Here this is known as the concavity at the top now. That is the effect of the beam, the effect of the bending moment. If it is bends the beam in the form of concavity at the top, then the type of bending moments are treated as a positive now. That means it is in the form of U shape. Generally, this effect is called here now sagging effect now. So, the bending moment, that is the force which is acting on the body, if it is bends the beam in the form of concavity at the top, the bending moment created by that force is treated as a positive bending moment. Similarly, the bending moment which is acting on the beam in such a way that the effect of the beam, it bends in the form of convexity at the top as shown in figure 1D is taken as a negative. That is the inverted U shape now. This effect is called hanging effect and it is treated as a negative bending moment. Or in other words, the bending moment which are created by the forces which are acting in downward directions on simple supported beam are treated as negative bending moments. Here shear force and bending moment diagrams. The bending moment is said to be positive when the moments are acting on the section in anti-clockwise directions in the right side and clockwise directions in the left side. That is, if you take this beam now, here the positive bending moment is treated as positive when it bends the beam in the form of this U shape or in nothing but having sagging effect. Then it is treated as positive. So for this beam, in order to have this that sagging effect, with respect to the x-axis section now, the left hand side, the forces which are acting, if it is a created bending moment in such a way that the effect is in a clockwise directions like this, is the positive. Similarly, toward the right side, it should be anti-clockwise directions. Shear force and bending moment diagrams. Generally, the shear force and the bending moment diagrams are give the magnitude of shear force or the bending moment across the length of the beam, and also to find what is the effect now. So, in order to draw the shear force and bending moment diagrams, the axis of the beam is treated as the x-axis, and the bending moment as well as the shear force has taken as ordinate and length of the beam has taken as the abscissa as shown in figure now. The diagrams which are showing the bending moment as well as versus length of the beam is known as bending moment diagram. And similarly, shear force versus length of the beam is treated as the shear force diagrams. The shear force as well as the bending moment diagrams numerically calculated numerically at any given point when it is subjected to loads by using this diagram. And these diagrams gives us the distribution of shear force as well as the bending moment across the section of the beam. The following relations are important between the loading, shear force and bending moment at a point or between two sections of the beam. While drawing the shear force and bending moment diagrams, all the positive values are plotted above the baseline and negative values below it. Consider the left hand or right hand portion of the beam for drawing the shear force as well as the bending moment. Add the forces that is including the reactions normal to the beam on one of the portions. Example, from the right portion of the section, the forces on the right portion of the acting downwards is positive, while the forces acting upwards are treated as negative forces. Example, from left side of the portion of the section, the forces on the left portion acting downwards is negative, while the forces acting upwards is positive forces. Due to the point loads, the shear forces suddenly changes its signs and the values also changes suddenly, but the bending moment remains the same at the particular point. If there is no load between the 2 points, the shear force does not changes because here the shear force means treated as the unbalanced vertical force. Hence, when there is no force between the 2 points, that is treated as the pulse, remains constant. But the bending moment, the moment is treated as the force into distance, the product of force and distance. Hence, it is now changed in the form of inclined straight lines. If there is a uniformly distributed load between the 2 points, the shear force changes linearly. That is, the shear force is in the form of inclined straight lines, but the bending moment is follows according to the parabolic curve because it is a proportion to the square of the distance. This we will explain that problems later by using uniformly distributed load. If there is a uniformly distributed load between the 2 points, then the shear force changes according to the parabolic law, but the bending moment changes according to the cubic law. This is nothing but when uniformly varying load is acting, it changes. Here, the bending moment at the supports of a simple supported beam is treated as 0, and also the bending moment at the free end of the cantilever is also 0. Okay, this is the information regarding the what are the type of the beams, what are the different types of the loads that are acting, and what is the importance of the shear force as well as the bending moment diagram, and what are the factors that are affecting the deflection of the beam. This will learn. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.